Here we have problem 13-39. We have a tunnel that's been cut through the earth from A to B, and a pod that goes back and forth. And it wants to know how long would it take to go from A to B, and what would the maximum velocity be. I'm going to start by redrawing. There's the tunnel. A to B. Here's the center of the earth, and it goes straight up. So here's our y-axis. The length from the center of the earth to the surface of the earth is big R, and the length from there to our point where the little pod is we'll call little r. The distance from the center between A and B we'll call x, and the distance from there to there is s. So we're going to call this negative s and positive s, those distances. Okay, if we draw a free body diagram of the little pod, it has a force directed at the center of the earth. And according to the problem, because this change in height is going to be significant, we can't just use mg as the force. And so we're going to use mg times the length where we're at divided by the radius of the earth to give us the force. So we break that into components. So the component parallel to A and B is going to be mg little r over big R cosine theta. Now, looking at this one, we can tell that r cosine theta is equal to x, right there, r cosine theta. So we can write this as mg x over big R. Okay, so let's sum our forces. The sum of the forces in the x direction equals ma equals mgx over r. Now, we're actually on the negative side of x, so this is negative. So let's put a negative sign in front. There we go. M's cancel. So A is equal to negative g over big R times x. These are both constants. The g is 9.81, r is 63.28 kilometers. And we want to find, well, first we'll find velocity. So we don't have time, so we'll use the equation a ds equals v dv. Let's put this into there. Negative g over r x. And now instead of ds, we're going to do dx equals v dv. We'll integrate this from 0 to, we'll do half. Let's go from 0 to x, just for now. We'll integrate this from 0 to v. So now we got negative g over r, 1/2 x squared equals 1/2 v squared. So now we have an equation. If we integrate this from, not from 0 to x, let's integrate it from s to x. Yeah, because we're going to start at A, we'll integrate from s to where x is. Okay. So if I do that, let's rearrange. Oh no, I can put it in there. So from s to x, from 0 to v, So negative g r 1/2 from x to s equals 1/2 v squared. Cancel the 1/2s, and v equals the square root. Let's factor out a negative g over r s squared minus x squared. And that's v. Now if you find the maximum velocity, at the maximum velocity, x is equal to 0. So v maximum is the square root of g over r. G is 9.81, r is 63.28,000, because that's in meters, that's kilometers, times s minus 0. S is 2 million. And the maximum velocity is v equals 2,490 meters per second. Now we want to know time. So time, v, is equal to dx dt. So if we flop these two, we got dt is equal to dx over v. Putting v into there, we now have dt is equal to, I'm going to put the square root of g over r outside because that's those are constants. So let's put that in the bottom. dx over square root of g over r times the square root of s squared minus x squared. So if we integrate both sides, bringing it up here, the integral of that is t equals 802, which is the inverse of that, times the sine, inverse sine of x over s. And we'll do that from negative s to positive s, and t is equal to 2,516 seconds, or 42 minutes.